Okay. Okay, so we're going to be talking about molar mass and formula mass. Now, for our purposes, they're pretty much the same. So I don't want you to get bogged down too much in the details, but I'm sorry, not molar mass, molecular mass. Molecular mass and formula mass, for our purposes, they're pretty much the same. So don't get bogged down in the details. Now, but if you talk to a chemist or an active chemist, they will fight you over the terminology, right? So molecular mass is basically going to be the average of a molecule. So that's kind of like when we're talking about like sodium chloride. So here we have sodium chloride, and the way that the compound is behaving is by positive and negative charges. And so they're going to be interacting by those positive and negative charges. And so it's not truly, it's interactive forces rather than sharing of electrons, because, you know, sodium gave up its electron to chlorine and they just happen to be positive and negative and they get together, right? So it's kind of like, have you guys met that couple that is inseparable? They go to dinner together, they go to the bathroom together, they do everything together. They never separate it. They're always holding hands. They're always lovey-dovey, kissy kissy, PDA, stuff like that. You see them all the time. They kind of make you sick because they never are away from each other. Or you invite one of them, you're like, hey, it's going to be a girls' night out, and the boyfriend
The husband comes.
Right?
Oh my gosh, that's funny. Yeah.
Okay, so you guys are kind of aware of that, right? So it's kind of like that situation, right? They're two individuals, but they act as if they're one, okay? But in this context, you have a whole bunch of these guys together. So when you calculate the mass of it, is you're just taking the average, what we perceive as the average, right? So we know that sodium chloride, you have one sodium for one chloride. So that's going to be our average. Even though that there's 1,000 chlorides and there's 1,000 sodiums, you're just going to take the average of one, okay? Well, that's what that kind of means, okay? So now formula mass is like when something is covalently linked. So you have like a body, right? My body here, I have 2 arms, right? So can you just go pull my arms off and I still have a functioning body?
No.
No, right? Because I need my arms. I like to use my arms, right? So my arms are physically connected to the rest of my body, right? So that's kind of like when we're talking about formula mass, because it's one whole connected thing, because they're sharing of electrons, okay? So that's kind of like we're talking about carbon dioxide. So they're sharing, so they're like one unit, okay? So then when we calculate its mass, it's going to be the same way. Carbon dioxide, let's see, CO2, it's molar mass, molecular mass, formula mass. CO2, how many carbons do I have?
2.
Okay, so I have 2 carbons, you said? CO2.
Oh, no.
There's one carbon, 2 oxygens.
Okay, I know it's early. You gotta get that coffee in you, right?
Huh?
I said you gotta get that coffee in you, right?
I can't drink coffee right now, but yes.
Oh, you poor thing.
I know.
Okay, so if we look on the periodic table, that's going to give us our atomic mass for carbon. So what is the atomic mass for carbon?
Carbon is 12.
So we have 1 times 12. And that equals 24, right?
No.
1 times 12 is 12.
Well,
Oh, see, I caught you.
why are you doing that? You're so
You know?
funny. Don't do that to me.
I was like, wait, you said 24, but you wrote 12. You confused me. That was.
Oh, yeah, I know.
It's too early.
Because, see, you guys are sleeping on me. You can't sleep on me. You know who I am.
I know.
Okay, so then we have 2 oxygens. What is the atomic mass of oxygen?
2 times 16.
16.
Okay, 2 times 16?
Yeah, and that's
32.
32.
We add them together?
44.
You put 34. It's,
See, good. Okay, and since we're talking about a single molecule, we will say AMU, atomic mass units, or we'll just use U for short. And you'll see both ways used, okay? So, but that's because we're talking about just one molecule. So now when we're talking about the sodium chloride, are you going to count up all of these guys? Or are you just going to take the average, right? So what we're going to do, we're just going to take the average rather than counting up all of those guys, because then it gives us an idea. And so we're just assuming, you know, under the circumstances, we isolated just one sodium and one chloride and all the rest weren't there. So then what's going to happen? They're just going to connect together, right? So then in that case, we do exactly the same thing when we calculate its mass. So that's why I say, you know, it's not that important. Just remember, figure out who's present, right? And then figure out, and then you just add the masses. So sodium, how many sodiums do I have in sodium chloride?
You have sodium chloride. You have 1, right?
Okay, so I have 1 sodium.
Uh-huh.
And then how many chlorides do I have?
1.
Okay, so then I get 1 times sodium is what? What is the atomic mass of sodium?
23, right?
23, yeah.
And
Chloride is 35. 1 times 35, sorry.
so we're just gonna be a little generous. We're gonna say that 4, 5, right? Because there's that 4, 5,
Yeah.
kind of significant. So 23 plus 35.45, what is that gonna equal?
That's going to equal 50.45. Right?
It's gonna be 50,
Isn't it 58?
No, 58, isn't it?
58.
Yeah, 58.45.
Okay.
I'm trying to do simple math here. It's really early.
And you don't have no coffee either? Oh Lord, you're struggling really.
I know I am. It's so struggling. And I stayed up late last night too.
Okay, and the units again are going to be AMU or just U.
Dr. Henry,
Yes.
so when do we decide to leave the decimal and then when do we not? Like you have 35.45, but then in sodium, you just have the 23.
So what I typically do, if I have 0.00 something or 0.03 or 0.05, I usually kind of just ignore it, right? Because really, if you look at your periodic table, one periodic table will give you one value. It'll be 23.0457, right? And then one will give you, or sorry, sodium was what? Sorry, it's 22.990.
Yeah.
Right? So in that case, 22.9, what am I going to do with that? 99.
Round it up.
I'm just going to round it up because it's so close to 23, right? And then in the case of 35.45, it's kind of in the middle. So depending on who's all involved in it, you know, I could end up pushing it up or I can push it down. So I just kind of leave it just to be safe.
Okay.
So, but this is I'm glad you asked this, Matt, because this is kind of one of those things. So when I talk about sig figs, I'm not going to take that in consideration because I know that those numbers, right? Those numbers have been modified by whoever decided to write that periodic table, right? So I can't use that. So I don't know how exact they've been. So I don't want to use that for my sig figs. Okay?
Okay.
Okay, so the stuff that I get from my periodic table, I am not going to be using for sig figs. So then in that case, I'm going to rely on what's given to me. And I'll show you an example of that later on. So just kind of keep that in the back of your mind. And when I say it, say, hey, this is what you're talking about, right? Just point it out to me, okay? So that I know that you guys are listening to me and I haven't gone crazy, okay? Hey, no yawning.
Oh my
I
gosh,
can't yawn, you can't yawn.
I thought I was on mute.
Okay, so now I want you guys to calculate the formula mass of ammonium nitrate. Now, the very first rule of chemistry, very first rule of Fight Club, you ready? You want to make sure that you can identify the formula, right? So if you don't know what it is, how can you calculate the formula mass? Okay,
Mhm.
so can we do this?
Yes.
Can you give me the chemical formula for ammonium nitrate?
NH4.
Plus.
Okay, I'm gonna write down what you guys say. I'm not gonna say one word. So you said NH4, and then I heard plus. Okay,
And then for nitrite is nitrate, right? Nitrate. Oh, that's gonna be NO3 negative.
Yeah.
so what is that compound? Is it gonna look like that? Is that what I'm gonna write on my paper
No.
or my answer?
No, that's not your answer. So you have to do the same thing that you did with chlorine and oxygen. So we're gonna have to break it down.
But is this here? Is this ammonium nitrate? Or is this ammonium ion and a nitrate ion?
Oh, that's an ammonium ion and nitrate ion, right?
Yeah, because if you just leave this here, I'm gonna mark you wrong immediately, right?
Yeah.
So if it's worth 5 points, you just lost 3 points.
Yeah. So we have to
Okay.
combine them, right?
Okay, so how would I combine them?
We would. I just forgot about this one. We'd have. We don't use parentheses. No, we do use parentheses for this, right?
I don't know. You tell
Oh,
me.
no, no,
Wouldn't
no.
it
Oh,
just
I
be
know.
NH4,
You have-
NO3?
Yeah, you have to neutralize it.
So
Okay.
NH4, NO3. That is correct.
Oh, we just lose a charge.
Because it's what?
It's neutralized.
It's neutralized.
Okay.
Okay, so this is the chemical formula for ammonium nitrate,
Yeah.
right? So now I want to go ahead and calculate the formula mass. So how would I go about doing that?
Do
You
this-
would get the atomic mass for each.
I would get the atomic mass for each. So tell me, how many nitrogens do I have?
2
Nitrogen.
times 14.
Okay, so I have
And then
2 times 14.
4 hydrogens. So it'd be 4 times 1. And then 3 oxygens would be 3 times 16. It's 24, 4 is 32.
that's
You guys
gonna-
make me so proud. I love it how, remember I told you I like a little bit of drama? A little bit of drama keeps you awake. Are you guys awake? Have you woken up yet?
No.
Yeah.
So you guys
Should
are,
be 80, I think.
you guys are getting to the point where you guys are starting to, and that's an O, that's not 30. Put a little O. So we have what, 28? You're getting to the point where you guys are understanding things.
Yeah.
And I like that. That's really good. Is that correct?
Yeah.
So it's 80 AMU.
So you said 80,
Yeah.
and what are the units?
AMU.
AMU. And so you guys are fighting for, I got the answer. Wait, I want to share. I want to share. You guys have to learn how to share together. We're a team.
This is the drama you want, right?
Oh yeah, I know. This is what I've been waiting for. I was like, okay, they're going to be a battle and, you know. But that's good. It means development. You guys are developing really well. So proud. Makes me want to cry almost. Okay, so piece of cake. Any questions before I go? Let me go back a little bit. Before we move forward. Yeah, no, maybe. Good. I love it. Because if you don't slow me down, I'm just going to keep going and we'll finish the whole chapter and another 2 more. Okay. So now we're going to talk about the mole, right? It's not the little animal that comes out of the ground. I have a really cute shirt for my graduating majors that eventually I have to give to them when I get everything together. But talking about this mole, right? I want you, before we get started on the mole, I want to ask you a couple of questions. Can you guys tell me about those dozens? What is a dozen?
12.
How many?
12.
So you're saying 1 dozen equal 12? So if I have a dozen of donuts, how many donuts do I have?
12 donuts.
So if I have a dozen of underwear, how many underwear do I have?
12.
If Kayla has 12 husbands, how many dozen of husbands does Kayla have?
12.
Wow.
Okay, so you guys get it. Dozen is always going to be what?
12.
Okay, so now a mole is kind of like a dozen. Only thing, instead of 12, a mole is 6.02 times 10 to the 23rd of anything. So we could have a mole of stars. How many stars do I have?
6.02 times 10 to the 23rd.
Excellent. Somebody was listening to me.
Yeah.
Okay, so if Deandra had a mole of boyfriends, how many boyfriends would Deandra have?
6.02 times 23.
She'd be very busy.
Mhm.
So if San Juana had a mole of avocados, how many avocados does San Juana have?
6.02 times 10 to the 23rd.
Excellent. If Leslie has a mole of eyelashes, how many eyelashes does Leslie have?
6.02 times 23.
Okay, so this is your first tattoo. This guy is called Avogadro's number, and I used avocados earlier because a lot of times we'll call it Avogadro's number, right? Because that's easy for us to remember, right? So Avogadro's number is 6.02 times 10 to the 23. Okay, so 1 mole is equal to 6.02 times 10 to the 23. You'll also hear it called Avogadro's constant, right? So Avogadro's number or Avogadro's constant. And again, most of my students will call it avocados because it reminds you, right? So I'm gonna ask you a really hard question. Matthew, what is Avogadro's number?
6.02 times 10 to the 23.
Okay, so now I'm gonna have you guys do a little poll for me, and I want you to think really hard about this, okay? But answer it, everybody gotta answer. Don't hold back, don't be scared. 'Cause I know you guys get scared sometimes. And that's why you don't wanna answer. Okay, so I'll share. So those who chose $1 million or $1 trillion, $100 trillion, why did you choose $100 trillion? Anyone?
Because it's in dollars instead of pennies.
Because it's dollars instead of pennies?
Yeah.
Okay, that's interesting. Okay, so let me tell you, I don't care. Fuck it, I'll use pennies. I still do. I have this little tub and I just put all my pennies in there. But I figure if I have a mole of pennies, I could pay somebody in pennies to sit there and count my moles of pennies and change them to dollars. So I'm not worried about it. Drive it up to the bank, not a problem. They'll use their machine. It may take them a year to do it, but I have a whole lot of money. So let's talk about $1 trillion. How many zeros do we have for $1 trillion? Help me correct me when I'm wrong.
You have about
14, I think it was.
yeah.
Okay. So this would be the hundreds, thousands, millions, billions, trillions. So we can also write this in scientific notation. Gotta put the dollar sign because I like money. So this is the same thing as saying see, that's a lot of money, right? So if we have 6.02 times 10 to the 23 pennies, how many pennies in a dollar?
100.
Yeah.
Okay, which one is bigger? A mole of pennies or $1 trillion?
A mole of pennies.
More pennies.
Okay, so you know, I have no issues with pennies at all. If I can get a mole of pennies on any given day, I will take that over $1 trillion in a heartbeat. Wouldn't even blink twice. Okay, so the one thing that I want you to get out of this by understanding money, you guys all understand money, right?
Mhm.
Okay,
We love money.
we love money, right? We know we need money, so we learn to love it, right?
Mhm.
So it helps you understand how much a mole is, right? Now, the reason why we have to use moles in chemistry is because we have to try to measure stuff, right? And have you ever tried to sit there and measure atom?
No.
You know, just single atom. Okay, so I'm gonna put that on the scale, right? And get a weight for it. Yeah, you don't see anybody doing that, right?
Mhm.
So we have to use a mole to give us something that we can actually visually see and weigh out. Like you measure, okay, I'm gonna add 1 grain of sugar, 1 little molecule of sugar to my cake, right? You don't add 1 little thing of sugar. You add how much of a sugar typically to a cake? You're making a pound cake. Do any of you guys don't cook from the box? Make anything
No.
homemade?
No box.
You cook all your cakes from the box?
Yep, no,
So-
nobody's got time for that.
Do anybody know that? So the reason why a pound cake is called a pound cake, you know why they call it a pound cake?
Put a
No.
pound of sugar.
Because you put a pound of sugar,
Pound of
you put a
sugar.
pound of sugar, you put a pound of flour, you put a pound of butter, right? And you put approximately a pound of eggs.
Are you serious?
Yeah,
What? That's crazy. I didn't know that.
that's what
Can
it.
you imagine how much a slice is like per calorie?
Oh yeah, but it's delicious. It is so good. It's like heaven. A good pound cake. Mm, mm, mm. Okay,
I don't think I ever tried that.
that's how they always remembered it. That's why it got the name pound cake. Okay, so you guys get an idea, right? So ready to use this? Want to see how this comes into play in
See.
chemistry?
Yes.
Okay, so a sample consists of 0.25 mole, should be moles, of ammonia. How many ammonia molecules is this? So what am I going to use to do this?
You're gonna use your given.
Okay, what is my given? I'm gonna underline it.
It's gonna be 0.25 mole
Of,
of ammonia, I'm sorry.
okay? It's gonna be important because you're gonna be working with more than one chemical sometimes,
Yeah,
okay? So then what am I gonna do? I'm gonna write that down first, is that you're telling me?
yeah.
Am I gonna put that on the bottom of the line or on top of the line? So here's my
On
line.
the top,
Put it on the top.
yeah, because it's your given.
What is the chemical formula for ammonia?
For ammonia,
Yeah.
it's,
NH4 plus.
yeah, NH4 plus.
Is it NH4 plus? Ammonia, not ammonium?
No.
Oh,
Ammonium.
NH3.
NH3, that is correct. See, I'm keeping you guys on your toes today. Don't fall asleep. Okay, so then,
Okay, and then so since we're trying to look for a mole,
Okay.
we're gonna put down at the bottom 1 mole,
okay,
and that's gonna equal at the top it's gonna equal the 6.02 times 10 to the 23rd, because 1 mole equals that.
okay,
And then after that, we just multiply.
and those are molecules up top,
Yeah.
and a mole and a molecule are not the same. Did you guys hear that? You want me to repeat it one more time? No, actually, I want you to repeat it. What did I just say?
A mole and a molecule are not the
They're
same.
not the same.
Are not the same. That is correct.
So that's going to equal 1.5 times 10 to the 23rd.
Is that enough significant figures?
Yes, because we only have 2. And it's the 2.5 from the 0.25.
And I also want to make sure that I put my units,
Yeah.
right?
Oh yeah, so it's going to be what is it, AMU?
Molecule.
Oh, molecule, sorry.
Yep, if we did our crossing out, would have known it was molecules, right?
Yeah. You're right. Write that down. You know, I did have a question, Dr. Henry. I know that it automatically, we have our given and it says a 0.25 mole and then it's ammonia. So we just go by the 0.25. We don't really go in for the ammonia, right? Like the polyatomic ion for that one.
What do you mean? I don't understand what you're asking.
Because like I noticed that, you know how like you have, oh, never mind. Oh, because it's already there. So we don't really do anything with the ammonia, right? Because you know,
Ammonia is just to help us remember that we're talking about ammonia, right?
oh, okay. Yeah, okay. No, I just
Yeah.
wanted to make sure because like I know like sometimes like it can be like I get confused, you know, and I'm thinking
Okay.
that there's more to the equation. So I just want to make sure that I sometimes like I know there's going to be problems that include like other polyatomic ions and stuff,
Yeah,
but to
Yep.
simplify something so simple, you know, not to like overthink it.
yeah,
So
yeah. I understand what you're saying.
yeah.
Yeah, I do the same thing.
So that's why I asked that. Even though it's like kind
No,
of,
that's okay. It's yeah. Okay. Do you guys get this? Simple? Maybe? Hard?
Yeah. Hardest
pretty
part is
simple.
remembering how to put it in the calculator.
Remembering how, yeah, that's the challenge, right? Remember that EE?
Yeah.
Okay, so we ready for our next question, right? We got this. Everybody got a picture or written down? Okay. Come on. Come on. Okay, so molar mass. So we've talked about a single molecule. Now that you've been introduced to the mole, we often put things in terms of molar mass, right? And so an outlet it's the mass of 1 mole of any substance. That's what your molar mass is. So if we're talking about carbon, the mass of carbon, 1 mole of carbon is 12 grams. So we will often express it in terms of grams.
Yeah.
Okay? So grams per mole is going to be the units. Now, our mass system for the periodic table, and pretty much our mass system in general, is based upon carbon 12. Okay, so that's kind of like the founding thing for us. So we always know that that's going to be kind of like our starting point. Carbon 12, because carbon's life and carbon's a whore. You know, you always remember carbon. You will never forget carbon, right?
Mm-hmm.
Right.
So, and with that, knowing that, we know that carbon is going to be, for 1 mole, it's going to be 12 grams.
Mm-hmm.
Okay, so the atomic mass on your periodic table is also going to act as your grams per mole. So what is the grams per mole of, let's see, tungsten?
What?
What is the grams per mole of tungsten?
I have to look for it. Tungsten.
That's why I gave it to you. If I gave you the answer,
184
183
grams per mole
Yeah.
if you round it.
you said 184?
Yeah.
Okay.
Yes, rounded.
Okay. What about copper?
Copper,
63.5, so 64.
So about 64-ish, yeah? Okay. So you guys
Yeah.
get it, right? Pretty simple, not too hard. So if we want to calculate the molar mass of a compound, how would we go about that process? Would it be any different than calculating the formula mass?
No.
Okay, you guys look at me like I've lost my mind. What the hell did he just say? You have that look. Okay, so I'm going to ask you. So when you calculated the formula mass, what did you guys do?
Use the how many carbons we have or how many tungstens we have, and then we multiply that by its mass, right?
Yep.
So
So
it's,
how is that going to be any different than when you calculate the molar mass? It's going to be exactly the same thing. The only thing that's going to be different is the units. What is going to be the units
Yeah,
in this case?
grams, right?
It's going to be, is it going to be just grams?
No, it's going to be molecules as well, right?
No, it's
No,
not going to be
moles.
molecules.
Per mole.
Moles.
What was that? Somebody say it again?
Per mole.
Grams per mole.
Grams per mole.
Um,
Okay, so we don't want to mistake molecules and moles, right?
yes.
Okay, so let's start this out. Calculate the mass, and actually should be the molar mass. This is a typo. I got to remember to hit save next time.
Mhm.
The molar mass of calcium fluoride.
Mhm.
What is the first thing that I'm going to do?
Is
Identify calcium fluoride.
Okay, so what is the chemical formula of calcium fluoride?
one.
Calcium is Ca. And fluoride is F2.
Okay, so how many calciums do I have?
1.
And calcium weighs
40.
40.
okay. How many fluorines do I have?
2.
2.
And fluorine weighs
19.
So we have 40. And what is that? 38. So we add them together, and the
70
mass of my compound is going to be what?
78.078.
What? What are the units?
Grams per mole.
Oh,
Grams per mole. So we can leave it at 78. That'll be good.
Oh, so we don't have to add the additional 0.7?
Yeah, because it's 0.07, right?
Yeah, oh, okay then. I'll just do that.
Piece of cake?
Yeah.
And to be exact.
Doctor,
Yes, Andy.
where do you get 1 times 40?
Where do I get 1 times 40? How many
Yeah.
calciums do I have, Andy? In this formula, how many calciums are here?
40.8?
How many?
40.8, right?
Yeah, so calcium weighs 40.8. I just rounded up because it's 40 point, isn't it 40.08? Isn't it this, Andy? Isn't it right?
Yeah.
So I can just round up or round, right? So if I round, I look at this, even if this was a 1, this is still going to be 0, right? So then I could just say 40 because it's so close to 40. Where the other one, fluorine, is 18.999 or something like that. So if I round this
998.
guy, it's going to be 19, right? Oh, 8.
Mhm.
Do you understand?
And then 2 times 19 gonna be not the 38, or 2 times 19?
2 times 19 isn't 38?
No, it's 38. But why you do that?
Why do I multiply it by 2? How many
Yeah.
fluorines do I have?
Oh, okay, got it.
Okay, piece of
Yeah.
cake. So that's why we need to know the chemical formula. If your chemical formula is wrong, what happens? Do you get the
Wow.
right molar mass?
No.
No, right? So that's why it's important. You need to make sure that you have your chemical formula because that's what you're going to use to calculate your molar mass.
Oh, okay.
Okay. Now, do you see why it all plays together? That's why I'm beating it to you. You know, I know you guys felt it. I was getting that whip out. I was like, psh, 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 you know? Do you guys see that? I have to email my sister. That just reminds me.
Mm.
Okay, good. Are you guys good?
Yeah.
Aaron, are you with me?
Yes, doctor.
Okay. I thought she was going to call me Uncle Henry again.
No.
That's gonna be your new name. We're gonna call you Uncle.
Oh my God.
Okay, so now this is something that I really want you guys to understand, conceptually understand. On this figure here, this image here, right? We have 1 mole of everything, right? We have 1 mole of iron, we have 1 mole of mercury, we have 1 mole of copper, we have 1 mole of aluminum, we have 1 mole of sodium, right? But they all have different weights associated with them. They all look like they're different quantities, right? But if you look at it, they have exactly the same number of molecules, right? 1 mole. How many moles? How many molecules are in 1 mole, or how many atoms are in 1 mole?
6.02 times 10 to the 23rd.
That is correct, right?
Mm-hmm.
So even though like you weigh something and it has a different weight, right? So for instance, iron weighs 55.8 grams per 1 mole. So if we weighed 55.85 grams, we have the same number of iron atoms as if we weighed the nitrogen gas, which is 28.02 grams, right?
Mm-hmm.
They would have the same number of molecules there, or atoms, you know? We'd have how many molecules of nitrogen gas if we had 28.02 grams?
How many what, I'm sorry?
How many molecules of nitrogen gas if we weighed 28.02 grams of it?
Wouldn't it be the same thing?
As what? What's that number?
6.02 times 10 to the 23rd?
Okay. So, but you look how much room that gas is taking. Look how much room that iron is taking. Is it the same amount of room?
No.
No.
No. Okay. So that's the point that I kind of want to get across. It's kind of like, for instance, you have apples and you have grapes,
Hmm.
right? So are your grapes going to weigh, I have 5 grapes and I have 5 apples. If I have 5 grapes, is that going to weigh exactly the same as my 5 apples?
No.
No.
But quantity wise, are they the same?
Yes.
Yeah. Mhm.
Okay. So that's that same thing. Okay. So you got to be aware of that when you're working with chemicals. I mean, it's funny because, you know, sometimes, even though we're not in the lab, you guys get in a lab and you're like, well, I weighed 5 grams of sodium hydroxide and, you know, it's telling you to weigh, you know, so many grams of the other thing. You're like, well, I put the same amount in both. And I'm like, well, it's not the same amount. It quantitatively, they're different. Mass wise, you may have weighed 5 grams of this and 5 grams of that, but that doesn't mean that they're going to be equal to each other in terms of quantity, because reactions are going to be based upon how many molecules you have. It's based upon quantity, not mass. So that's going to be the golden rule. We're basing it upon quantities. So when you look at a chemical reaction, it's not going to be based upon the mass. You're going to put equal masses of things. You're going to make sure that you have the quantities so that the reaction will be able to behave right. I'll give you an example because you guys are looking at me like I'm crazy, right? Don't worry, we'll get there. Okay. Let's see. So you are carrying out a laboratory reaction that requires 0.0360 moles of barium chloride. How many grams of compound do you measure out? So what am I going to do?
You're gonna do, we're gonna get user given.
Going to use my given. What's my given?
Your given is 0.0360 moles. And it's gonna be slash barium chloride 2.
Okay, so give me the chemical formulas, because, you know, I'm just learning chemistry. I can't remember anything. Help me out. What are those symbols?
So for barium, it's just gonna be just Ba. And then since it's chloride, there's 2, right? So it's gonna be two chloride, yeah.
Good job.
I just always have to remember because I always get confused with the chloride and chlorate. I don't know, a chloride.
But you got it down, right? You remember that 8 means there's going to be some oxygens in there.
Yeah.
And odd means there's no oxygens,
Yeah.
unless it's oxide. Okay, so what am I going to do with this? This looks beautiful, but I'm supposed to get grams. How do I do that? This is what I want. I want grams.
Right. So we're gonna do is since we want grams, we're gonna have to do the I forgot the name of it.
Get the atomic mass.
Yeah, we have to do the atomic.
Okay, so how do I calculate the atomic mass? I'm Andy. I don't remember, right, Andy?
For
Yes.
barium's gonna be 137.33 grams.
I have
per
1 barium, or I have 12 barium.
one.
1 barium.
And you said it's 137.33?
Yeah.
Okay,
And one
And?
chloride, or 2 chlorides.
I have 2 chlorides.
Yeah. So you're going to multiply that times its mass. So it's going to be 35.45.
Okay, and then what do I do?
Oh, you're going to add.
Add up
Mhm.
208.23 grams per mole.
So Dr. Henry, do you want us to just always use these decimals for good measure? Or is it either one going to be acceptable?
Either one is going to be acceptable. Long as you don't do anything crazy, like here, this ends up being 0.9. If you just neglected that 0.9, it's going to throw you off, right? Because it's such a big number. So long as you don't do anything crazy, then you're going to be fine, So if you said 208, that would be fine. Now, what I'm more concerned about is making sure you have sig figs. And so what am I going to use for my sig figs? Oh, by the way, where am I going to put this? I don't know. It looks so pretty.
Yeah, it's going to go on the top.
It's going to go on the top.
Yeah, because you want, it's going to be 1 mole
At the bottom?
at the bottom. Yeah, and it's going to be barium chloride too.
Okay.
And it's going to equal, the top is going to equal the 208.23 grams barium chloride too.
Okay.
So that means that the mole gets crossed off, right?
Yep.
Yeah.
And then now we're left with grams.
Yep. I'm going to start thinking you guys have been doing homework, talking to Jessica. Make me so proud. Reading the book. Okay, what is your answer?
7.50 grams. And that's going to be barium chloride too, right? Is that what it is? Yeah.
That is correct. Piece of cake.
So far.
And this is when it's asking for grams of a compound, right?
Yep.
Okay. Just want to make sure.
Or they'll just say of that particular compound that you're looking for. Yes.
Okay, cool.
Okay. Okay. Are you ready for the next one? You ready to move on? Any questions? Okay, I like that. Can I erase? Or do you need a second? You can talk. It's okay. Say
Yeah,
yes,
okay.
Dr. Henry.
Yes, erase.
Yes.
Okay. Okay, so take home message. This is just a summary slide, right? So if I'm giving quantity, which they'll often use as units, it's kind of funny. Be careful with that. So quantity, so if I'm giving molecules or atoms or underwear or, quantity, then I'm going to use Avogadro's to change it into moles. If I'm given moles, then I can use the molar mass to change into grams.
Mm-hmm.
Okay? And I can go back the other way. So if I'm given grams, I can use the molar mass to change into moles. And if I'm given moles, I can use Avogadro's number to change into quantity. Okay, you guys get that? Okay, so I'm gonna say you guys got it because you guys are not answering me. So I'm just gonna keep going. Let's go. We'll just skip this. We'll just go to the next chapter. Right? Next 3 chapters.
No.
We'll put those on the
Don't
test
no.
right now.
Slow down.
But you guys aren't telling me nothing. I don't hear anything, so I don't know.
I want to go back to previous screen.
You want me to go to the previous screen?
Yeah, because I have to write them down. So
Okay. So let me know. Talk to me. There you
I
go.
was writing and you go. So,
Can we try one of these?
We're gonna try one of these.
Okay.
yeah.
Did you turn the AC? It's cold. Oh. Yeah, please.
Okay, are you ready, Andy?
Yeah, I took a picture already.
Okay.
Yes.
Okay, so this is just saying exactly the same thing I just said. Exactly the same thing I just said. Okay. And it's just a box image of it. Okay. So let's try an example. Determine the mass in grams of 3.2 times 10 to the 23rd molecules of sulfur tetrafluoride.
So we're going to use your given.
Okay.
That's going to be the 3.2 times 24 molecules. Sulfide tetrafluoride. Sulfur tetrafluoride.
Okay. So you said 3.2
Mhm.
times 10 to the 24.
Yeah. Sulfur tetrafluoride.
And that's molecules of sulfur tetrafluoride. Oh, sorry. I got ahead of myself. I'm new at chemistry. I'm a chemistry virgin. So how do I name this?
Would it be SF4?
Yeah.
Okay.
And then since we're using molecules, then we would use a 6.02 times 10 to the 23rd.
Where am I going to use that at?
You're gonna put it on
At the top?
no bottom.
And the units on that is what?
It's gonna be molecules and then sulfur and tetrafluoride slash yeah.
Dr. Henry?
You don't have to put slash. You want to just put it as those units.
Oh, just put it. Oh, okay. I wasn't too sure. 'Cause I know we do that.
Then what's on top?
1 mole
1 mole. Of what?
of sulfur fluoride. I mean tetrafluoride. I always forget that part, and it's so important.
Okay, so what were you going to ask me, Jessica?
That's where I'm getting a little confused because I thought that the mole and molecules are not the same thing. So
They're
why
not.
do we put the 6.02 times 10 to the 23rd molecules?
because
There.
6.02. So a mole and a molecule are not the same thing, right?
Right.
They're not the same thing, but they can be equal to each other because we know that 1 mole. So what I'm saying is 1 mole, that term mole does not equal molecule, right? Doesn't equal 1 molecule.
Okay.
Okay, that's not true. How many molecules does 1 mole equal if we're talking about a molecule?
I see. Okay.
Okay, so they're not the same, because often when I was taking chemistry, when the instructor said molecule, I would always mistake that for a mole. I did that for about a whole week, and then I'm like, oh God, I'm an idiot, right? They're 2 different things. Do you understand?
Yeah.
Okay. So, but I can also, I mean, 1 mole could be an atom if we were talking about iron only, right? Because then it's 1 mole could be 6.02 times 10 to the 23rd atoms. Do you see what I'm saying?
So really quick, Dr.
Yeah.
Henry, just to specify, 6.02 times 10 to the 23, 1 mole, that's how many molecules are in 1 mole?
That is how many, if we're talking about a molecule. If we're talking about molecules, yeah. But if we're talking about atoms, then it will be atoms. It'll be 1 mole is equal to 6.02 times 10 to the 23rd atoms. If we're talking about your girlfriend, right? You have a mole of girlfriends. So then 1 mole is going to be 6.0 times 10 to the 23rd girlfriends.
Okay.
Just like a dozen, right? Does a dozen only pertain to donuts?
No.
No.
Because you can have a dozen eggs, you can have a dozen of husbands, right? Okay, are we good?
Yeah.
Okay, so then what do we do next? Are we done? Oops.
No. So now we're gonna do the atomic pictograms. We have to know the atomic mass for sulfur and then tetrafluoride, right?
Okay, so how many sulfurs do I have in sulfur tetrafluoride?
So we have 1. And then for the mass is 32.06.
I'm gonna be lazy. I'm just gonna write 32.
Okay. And since tetrafluoride, tetra is 4, we're gonna multiply that with
19.
yeah.
Okay. So that's 76.
Mm-hmm. And then that's going to be 108.06 grams. And then per
Is
mole.
it just grams?
Yeah, just no grams
Grams.
per mole.
Grams per mole.
Yeah.
Okay, so 108.
0.06.
I'm being lazy.
So then we'll put that in at the top, right?
Mm-hmm.
Okay. So I'm gonna put 108 here.
Mm-hmm.
And
Oh, and then that one's going to be 1 mole.
Per
So,
mole.
yeah, 1 mole sulfur fluoride 4. So I can cross out.
this is gonna equal
6.02. It's going to equal It's gonna
5.57.
yeah, 5.57. But let me see if this only has 2 sig figs, right?
Yeah. Yeah, so it's just going to be, oh crap,
No,
5.5.
no, it'd be 5.570
5.7.
grams. So,
How am I
Are you
getting
sure?
5.57?
This is what I got when I plugged into my calculator.
Don't we
no,
divide it?
it's not 5.5. Sorry, it's 5.7. I got 5.74.
Okay.
But last night you said, Dr. Henry, that it would be 5.70 because we only have 2 sig figs, right?
Okay. Is that true?
Yeah, because we have
Okay.
the 3.2.
Yep. So then I need to put my 0 as my placeholder, right? So then it
Yeah.
should be
Uh-huh.
570.
Okay.
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 How am I I must be entering this wrong. Because I keep coming up 5.570979.
Okay. So what you need to do is, what type of calculator do you have?
I'm just using my phone right now.
Oh, you're just using your phone? Excellent. Okay. Let me pull up my phone.
Let me see.
I need to figure out who has my Casio.
So
I'm putting the 10 EE. I don't put the 10, do I? Just put the 6
Yeah.
point.
So yeah, you want to put just EE.
Okay, that's what I'm trying.
So 3.2 EE24, and then times 108 divided by 6.02 EE23.
So even if excuse me, if it was still say theoretically speaking, if it was 573, 572, then it would still be a 0, right?
Yep.
Okay.
So, but if it was 579, what would that be?
So it'd be 58. Would it still be 580?
It'll be 580.
Okay.
It's kind of like you don't want to get rid of that 0 because that 0 is a placeholder, right? So if you earn $570, let's say $574
Mm-hmm.
to be exact, you earn $574 and I paid you $57.
Yeah.
What would you do to me?
I'll be mad. I'll sue you.
Okay. So, but if I paid you $570, you'd be like, okay, I'm not going to get too pissed off because it's only that $4, right?
Yeah. Mm-hmm.
Okay. So always think about it. Think about it in money,
Yeah. You're right.
So
Money.
that 0 is just a placeholder to make sure that I'm giving you the right amount.
Okay.
See, this is why I miss doing this in class, like face to face, because I earn so much money this way, right?
You're funny.
And then after people lose their money, they never forget sig figs.
Yeah. But that's good to know because I was just gonna go with the 4, 574.
Mm-hmm.
And then I remember you were talking about turning into a 0 because we need a placeholder.
Yep.
Okay.
May I ask a question, Dr. Henry?
Yep.
In the lower left-hand corner, is this supposed to be SF4?
Oh, thank you. See, you guys keep me on my toes. I did it on purpose. I was going to see how long it took you guys to figure it out.
Yeah, I'm still not getting this.
You're not getting what?
I don't know. I'm not. Where's the lid? Here.
Oh, in your calculator?
Well, I mean, I guess what are you just doing the 3.2 times and then the EE24? And
No,
then
you don't put times. So you don't have to put times. All you need to do is put 3.2 EE24.
Not in a calculator.
And then I'm timesing the 6.02 EE23.
You're dividing it, right?
Inviting.
Because it's at the
I'm
bottom.
messing up. Okay. Got it. Hello. Okay.
Did you get it?
Yes.
Okay, I divided.
And
And then
okay, so that was Tiffany, right?
Yes.
Okay, I'm not trying to call you out, but this is a good example why on the short answer questions, you want to show your work, because a lot of times you do everything in your calculator and you enter it wrong. If I see that, I will mark some of your answer wrong because you gave me the wrong answer. But I see that you set it up right, and then I recognize that you know the material, you just didn't enter in the calculator right.
Okay.
Okay, so I'm just using you as an example because the last exam, I had about a dozen of people that did exactly that, and they just gave me an answer rather than showing me the work, and they all got it wrong.
Alrighty.
Okay, so that's the
So,
difference between 0 and maybe some points, you know.
Yeah.
And all those points, they add up real quick, right?
Yes.
Dr. Henry, so
Yes.
the final answer is 570 gram SFO.
Yep, that will be the final answer.
We're not approximating anything. No sig fig, sorry.
That's already including our sig figs. That's with sig figs. So if we didn't use sig figs, it would be 574. I'm sorry, 570 would be the correct answer after sig figs. 574 grams, that would be before you've done the sig figs. Right?
Okay.
Does that answer your question?
Yes.
Okay.
Thank you.
You're welcome. Good job. Good job. Are you guys feeling it? You feeling the chemistry? Is it just exuding out of your pores? Come on, tell me. You gotta tell me. I want to feel it. Come on, Anna. Give me an expression. I almost got a smile out of her. Almost. It was that close. You're almost there. Okay, so you guys ready to move on?
No,
No. Why not, Andy?
no, because I still don't get it. 3.2, you know, and then I divide by 6.02, and then I time 108.
Okay. Oh, you're saying that you don't get it on your calculator, or you don't understand what we're doing?
I don't have an EE in my calculator. I just use 3.2, and then divide by 6.02,
Uh-huh.
and then time 108. I get
Uh-huh.
57.24.
Okay, that's because you're forgetting the times 10 to the 23rd and 10 to the 24th, right? Because it's not just 3.2, it's 3.2 times 10 to the 24.
Need to do that.
Yeah, you have to do that.
Then I need to get another calculator. And
No, you can use your calculator. What calculator do you have?
no. I have a very simple one only.
Show me on your screen. That means you got to turn on your camera so I can see it.
I'm so ugly today. This one only.
Hold on. See, you moved. Give me one
Is
second.
it?
Let me find you. Hold on. Let me find you, Andy. I see it. Yeah, you can do it with that one.
Yeah?
Yeah. So look on there. There'll be a thing that either says, it'll say either EXP or it'll say EE. Capital E, capital E. Look on there. Do you see anything like that?
No.
Are you sure?
Very sure. I have more as to log in on ABC.
Do me a favor. Show me your calculator and I'll find it. Let me zoom it. Okay, scroll down. I mean, push it up a little bit. Up, 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 up. Okay, let's see. Up just a little bit. Okay, you don't see that thing that says capital EXP in big letters at the very bottom there, in that bottom row, EXP.
Oh, okay.
Okay, so that'll be $755. Okay. Okay, so that means that when you type it in, what you're going to type in, Andy, you're going to type in 3.2 EXP 24. Okay, so that EXP stands for 10 to the whatever power. Okay.
And divide by
And then you're going to divide it by 6.02 EXP 23.
And then I time.
And then you're going to multiply it times the 108.
Oh, got it.
You got it. See? Look at that.
Oh, let me write them down. 32 EEXP. Let's see. I get it. Thank you, doctor.
I think we need to offer a class at West Hills on calculator use.
Yeah. Making me
Yeah,
feel
I
old.
Well, it makes it hard, and the thing that makes it hard is because there are so many different styles of calculators, right? So you have the EE, you have the EXP, and some of them don't have either. Some of them just have 10 to the, you know, and some of them have them both. And so you're like, which one do I use? When do I use it? So maybe that's what I'll offer. It'll be a mini course.
Yeah, that's better.
Yeah, that would be a good summer course. Chemistry,
Yeah.
not so much. Yeah.
Okay, are you ready?
Yeah,
Can I race now?
yes.
Okay.
Okay.
Okay, everybody's on the same page, right?
Yes.
Okay, so let's make it a little bit harder because you know this is too easy. You guys are just whipping through it like bread and butter, right? Okay, so the next thing that we're going to talk about is percent mass. Okay, or I call it percent mass. It's often called percent mass in industry, but it's also called percent composition by mass. Okay, so all it is you're taking the part over the whole. Okay, so for instance, if we're talking about the percent mass of fluorine in calcium fluoride. So what does calcium fluoride look like? What is the chemical formula for calcium fluoride?
CaF2?
CaF2. Okay, so we're interested in the fluoride in the calcium fluoride. How much of it is fluoride in calcium fluoride? Well, the way you calculate that is you take the part of the whole. So what was the molar mass? Can we calculate the molar mass of calcium fluoride?
Mm-hmm.
How do we do that?
It's by doing the, so we're gonna write out 2 fluoride
2 fluoride,
times its mass, so it'd be 19.
okay. So 2 times 19,
Yeah, and then for calcium, it would be, since it's 1 calcium, it'd be 1 times its mass, which is 40.
okay. So we have 40 plus 38, oops,
78 grams per molecule.
Yeah,
Okay.
grams per molecule.
is it grams per molecule?
Crap, no, it's mole.
It's mole, I'm sorry.
Okay.
This is gonna be bad.
Okay. So 78 is our total, right?
Mhm.
This here, 38 is the fluorine in calcium fluoride. So all we would do is put 38 divided by our total,
Which is 7.
Times it by 100.
Mm-hmm.
and we multiply by 100 because it's percent mass.
Okay.
Yeah.
So we're assuming that we have 100 of whatever we got. Okay, so then that's gonna equal what?
48.7%.
Yeah, mass. I think it's fluoride.
You said 47,
48.7.
48.7%. Okay, so if I wanted to calculate how much calcium is in calcium fluoride, how would I do that?
It's gonna be 40 over the total times 100.
So 40 over 78. So has anybody seen Eileen?
No. Yeah, she
Well,
hasn't
y'all
been in
better call her.
contact.
Somebody better check on her. She may have the COVID. And if she don't have the COVID, tell her Dr. Henry's looking for her.
Hmm.
Tell her I miss her laugh. And she doesn't keep Roe in check. I need somebody to keep Roe in check. So, although Judy does a decent job, but she's not quite to Eileen's level. So what is this number? 51.3? Is that correct?
Yes.
Piece of cake?
Yes, I like this one. It's easy.
It's all
No,
easy, right?
The only thing is,
What was that, Andy?
because the only thing is, like you say, calculated the mass percent of fluorine in
Mhm.
calcium fluorine. The fluorine, how come you always have two?
You don't
like-
always have two, you just happen to have two, right? Because you're pairing up with calcium. What is the charge on calcium, Andy?
Oh, calcium is
Calcium
positive.
ion is going to have what charge?
The charge.
Yep, calcium ion.
Is it positive?
Is it just one positive? Where is it located at?
Two.
It's two positive, right? So it's going to be Ca2 plus, right? So how many fluorines am I going to need to balance it out, Andy?
Two there.
I'm going to need two, right? Because each fluorine is a -1. So
Uh-huh.
remember, it has to neutralize. If it doesn't neutralize, it don't work. Right?
Okay.
Okay? So
Okay.
don't forget that. Remember, we're building this house. You can't, if you don't put that foundation down, right? Then what happens to the house?
We have a basement.
We have a basement.
Oh.
It falls down.
Right.
You don't have a basement. You have nothing.
No, in PA have basement. All the time better. In California, basement.
Are you guys ready? Next one. Did you get it?
Yes.
Okay. Let's see. Are you there?
Yeah.
Calculated.
Oh, I got carried away.
Ah.
Okay. Calculate the percent composition by mass of ammonia sulfate. So in this case, we want to do them all. So we want the aluminum and we want the aluminum and whatever else is in that sulfate thingy. So what is the first thing that I want to do? You're telling me, Deandra, you got to put it on because I can't hear you. Are you muted?
No.
Oh, you're just far away from your.
Kind of like cutting off. No.
Okay.
Like I
hear
can
you
hear
now.
myself and then sometimes it'll cut off.
Okay, I can hear you now.
Okay, so you would write for aluminum,
Okay.
you would do the NH.
NH, aluminum.
NH4,
Are you sure?
or wait,
Aluminum and an ammonium.
oh, yeah, you're right. Sorry.
Oh, that's right. It's a common mistake.
Right. Kind of read it the other way.
Okay, so what would be aluminum?
Yeah.
Aluminum, it would
Yep.
be Al,
Okay.
and then for sulfate, it would be S. And then,
2 or
No, because it isn't positive two and maybe two is the same.
What did you say, Kayla? S what?
2,
S2?
3,
S3?
I don't know. Let me-
I'm just writing down what you guys tell
SO4,
me.
2 negative.
What was that?
SO4, 2 negative.
S, you said SL?
Oh, SO4.
Oh.
Uh.
Oh, okay. I'm just hearing everything. SL4. And you said it's 2 negative? So that's what I would write? For my chemical formula?
You wouldn't write the negative.
I wouldn't write the negative? Okay. So is that the way it looks?
That or what?
No, you have to balance it out.
Well, we got to balance it out. So what do we need to do to balance it out?
Would aluminum have 2?
Two. That was SO.
Okay, aluminum would have 2.
So that would be 2, and then the negative 2 would be equal.
Okay,
Equal.
so you're saying now it's equal?
Yeah.
No, because
No,
We have to neutralize it.
Oh, we got to neutralize. So it's not
Yeah.
neutralized? So what is the, I'm confused. Y'all are confusing me. Oh, you guys, I'm confused. I'm a hot mess. I'm just learning this stuff. So AL, you're saying, somebody said earlier, AL has a what charge to it?
3 plus.
3 plus. And then
That'd be
sulfate.
Al2SO4 3, right?
Oh yeah.
Ah,
we'll have
there
a
we
3
go.
at the end.
Al2SO4 3. That makes sense now. Okay. So if I'm putting these together, I'm going to need how many of these to balance this out?
three
2.
and
Okay. So that would be 6.
Yes.
And this would be negative 6.
And it's,
And I add them together, that equals 0.
mhm.
See? And then, so I can write it like this. Thank you. Piece of cake?
yes.
Now you see what I mean by nomenclature, right?
Yeah.
Yeah.
Because if you were putting down what you guys were saying, what you were putting down, what would have happened?
Got it wrong.
You got it really wrong, right?
Yeah. I always forget sometimes, like, because I automatically think that, like when you move on to a different topic, you're like, oh, okay, we did that. But in chemistry, everything is used.
That's right. So you remember when I told you guys what you guys did at the beginning? You're like, okay, so all the stuff I learned in math, I'm just gonna dump that shit out, right? So I'm ready
Yeah.
now.
You gotta make room for the new stuff.
Yep. Well, chemistry is like, okay, nope, you got to keep it, right? Okay, so let's go ahead and add on to this, right? So it says calculate the percent composition by mass. So how many different elements are we working with?
3.
2
3.
or 3. Sorry, yeah, 3.
Okay, 3. So tell me the elements.
Aluminum,
Sulfur, and
sulfur,
oxygen.
and oxygen.
Okay, how many aluminum do we have?
2.
How many sulfur do we have?
3.
And how many oxygens do we have?
12.
Okay, so I really don't get this. So why do I have, I only see 1 sulfur here. Why do I have 3 of those?
Oh.
So there's the 3's outside of the parentheses.
Outside of the parentheses.
Ah, so that means I have to multiply both, everything inside of the parentheses by that 3. Okay, I get it. Okay. So we have 2 times, what is the mass of
27.
aluminum? I always forget.
27. Or 26.982.
So 27.
And
Okay.
then sulfur's 32.
So 3 times 32.
And oxygen is 16.
And that's 12 times 16.
It's 192.
So this is 192.
Mm-hmm.
Should be 342, I think.
3 times 32 is 96. 2 times 27 is 54.
Dr. Henry, I have a
Number.
question.
Yeah.
Are we not adding the fraction in sulfur? Like
The
3.2, 32.06?
32.06.
Yeah.
And we're just dropping it because it's 32.06. Isn't that just roughly 32?
Mm-hmm.
Right? Because it's like 32.1, right? That's pretty close to 32, is it not?
Yeah.
Yeah. So if it was like a 4 or 5, or if it was like a 7 or something like that, then we have to take it in consideration, right? But
Okay.
since it's so low, you know,
Okay.
it's not gonna have an impact.
All right.
Okay. But you can if you want to. I mean, I'm not gonna mark it against you, but I'm
Okay.
lazy.
Okay.
I'm just being honest. So if I added these together,
342.
and the units,
Grams per mole?
grams per mole.
Oh, okay.
Okay, so if I wanted to calculate the percent mass of aluminum in aluminum sulfate, what is it going to be? How am I going to do it? I want percent. Oops. I can write percent mass.
You're gonna use it. You're gonna use its total divided by the ultimate, like so it'd be the 54 divided by 342 grams per mole, right?
Okay, so I'm going to use my mass, my atomic mass of aluminum.
Yeah. And then you're gonna also, when you divide that, you're gonna multiply it times 100.
Okay, and I'm dividing it by 3. You said 342?
Yeah.
And multiply that by 100.
And then you get, let me see how, it's gonna be 16. 16.0? No?
Yeah.
Okay.
Is that right?
So I'm just going to say 16. So I don't have to worry about sig figs for this one.
Okay, cool. I was gonna ask you that, like, do we have to worry about sig figs on this one?
Well, again, because you're using your atomic mass, the
Yeah,
atomic mass are not going to be exact,
okay,
and the sig figs are going to vary from periodic table to periodic table. So,
okay. 16%.
so let's say mass of sulfur.
So it's gonna be 96 divided by 342 times 100.
You want to know?
28%.
Yeah, it's gonna be 28%.
Get it, Andy? You have it. Look.
SO2. I still try to figure out. Okay.
Times.
SO.
You said 28?
Yes, 20.
Yeah.
And oxygen?
Will be the 192 over the 342
Um,
times 100.
And that's gonna be 56%.
Thank you. Gracias.
Okay, piece of cake?
Yeah, this is actually pretty easy. So the main thing is just getting the formula right, and then from there, everything else is pretty simple.
Let's plug in.
That is correct.
Oh,
This isn't part of exam 2, is it, Dr. Henry?
This is part of exam 2.
Oh, it is?
Mm-hmm.
Oh, okay.
But the well, you're gonna have a lot on nomenclature, right? So more
Yeah.
focus on the nomenclature, but you're gonna have some questions dealing with this.
Okay.
Okay.
Okay. Are you ready? Next part.
Yeah.
blah, blah, blah.
So I can erase?
It's Dr. Henry.
Yes.
You know the 12.
Yeah.
The 12 Austrian. I know you get 12 Austrian by 4 times 3 here, right? In
Yep.
SO. So how come we have to put a 4 in the middle there and then times 3? And we don't do it here like 3 times SO and it was 6, 2 times SO EL equals 6.
I don't understand what you're asking. So you're asking, okay, so you know where the 3 comes from, right?
The 3? The
Yeah.
3 come from SO, right? The SO4?
So we need 3 SO4s to balance out our aluminum, right? So if we have 2 times AL is plus 3, right? It has a plus 3 charge. So that's going to equal 6, is it not?
Yeah.
2 times 3, it's going to equal 6, right?
Yeah.
So then I'm going to need how many SO4s to balance out that 6 charge? I'm going to need, so if each one is -2, 3 times -2, it's going to be -6. Okay, so 6 minus 6 is going to be equal to what?
0.
0. Okay, so then my chemical formula is going to be Al2 SO4 3, right? I needed 3 of those to balance it out.
Well, yeah, I know, but how comes SO4?
Because what is sulfate? What does your polyatomic ion say about sulfate?
Sulfate is SO here, they don't have SO over here. They have to.
Are you sure? It doesn't say SO4. Take a look. Now, when I show you that it does, you're going to give me $10.
Oh, come on.
So you better look hard.
Let me see. I don't see SO here.
SO4. Look what SO4 is. Look for the word sulfate on your polyatomic ion table.
It's the SULLUR. It's sulfate.
Look for SULFATE. Look for sulfate.
They do have it?
Yeah.
See.
Do you want me to point it to you? Okay. When I point it to you,
I don't give.
look, because when I show you, I'm expecting $10. I take Venmo.
Okay. I keep. Never. I don't keep on generous.
Did you find it?
No, I lost $10.
Okay.
It's on there. It's on there more than once.
It's on there, Andy.
It's on there twice.
Are you looking at your polyatomic ion table, not your periodic table?
God, God, okay, I know it now. Right.
Okay,
Oh,
so,
okay.
okay, Andy, we're gonna tell you this one more time. You've got to
No, I
use
don't.
all your resources. And just also, this here, SULF, should bite you. You should say, oh, that's a sulfate, right? Sulfate means that there's sulfur and oxygen. The ATE, that means there's oxygen attached to some other element. SULF, sulfur, right? Sulfur and oxygen is going to give you sulfate. So you should say, oh yeah, polyatomic ion table. So anytime that you see ATE, you should go to your polyatomic ion table. Where's your polyatomic ion table? Where is it? You got it?
I pin them white out now. I know it now. I pin them
Oh, you
white.
know it now, huh? Okay, so next time you ask me that question, it's going to be 20 bucks.
Okay.
Each time I'm adding 10 bucks. I'm going to earn a lot of money this semester. Since I'm not in class, I can't earn my money my normal way.
God, it takes a long time to fill into so I am table. Oh my God.
Okay.
I'm pinning them out right now. Get a new one.
Okay, so you guys ready for the next one?
Yes.
How are we doing on time? We're doing pretty good. Got an hour and a half left. Okay. So, aluminum chlorate is 38.35% chloride. What mass of aluminum chlorate is needed as a source of 50.0 milligrams of chloride? Okay, so what am I going to do for this?
Aluminum chloride.
So you're gonna take your given.
I'll take my given.
I didn't.
What is my given?
30, or no, I guess we put at the top 50.0 milligrams.
So you're telling me my 50.0 milligrams of chloride?
Yes.
Okay. Okay.
And then we do 38.35% would be milligrams as well. So we put that on the bottom.
Don't we have to convert it
What do I have to convert it to?
to grams, right? Or milligrams?
Okay, so if I say 38.35 milligrams,
No, what I'm asking, like we can't do percentage, right? We have
yeah,
to.
but isn't percentage unitless?
And then you put the 100 milligrams on the top.
So if we make an assumption, so we're going to make an assumption. I have 100 milligrams of aluminum. What does aluminum chloride look like? I mean, aluminum chlorate look like?
Would be
AlClO3.
AlClO3, right?
Yeah.
Okay, so if I made an assumption that I had 100 milligrams of aluminum chlorate, how many grams of chloride would be in aluminum chlorate if 38.35% is chloride? How much of this is going to be chloride?
So we have to divide it and multiply it times 100 since we're using percentage, right?
Yeah, but in this case, right? So initially we're using percentage, right?
Yeah.
But in this case, we know that we making an assumption because we said 100%. So 38.35 chloride is, 38.35 of aluminum chlorate is chloride, right? So you're saying, basically all you're saying is, if I have 100 grams of aluminum chlorate, 38.35 grams of it is chloride.
Okay, yeah.
Right? Because if I get this, so now I'm bringing it back to the fraction, right? Because all it is, you're saying 100. This is the reason why we use 100%, right? You're just saying 38.35 grams or milligrams in this case, so milligrams, right? So that's going to be the same thing times 100, right? That's going to be the same thing as what we're saying here in terms of our percentage, right?
Okay.
Okay, so anytime that you're talking about percentage, right, you can change it to its fraction and say, oh, I'm assuming I have 100 grams of that, right?
Yeah. Okay. That
Okay.
makes
Okay, because that's going to equal that decimal for that, right? So then, what are we going to do?
So then we're going to multiply across and divide, right?
Yep. And we get our answer. What do you guys get?
1.30 grams aluminum chlorate.
You said 1.30 grams?
Yeah. I don't know. That's right.
Let's see, are you sure? Maybe my math is wrong. Hold on.
I don't know. No, I'm not sure.
I got 1.0.
50 times 100 divided by 38.
Dr. Henry?
Yep.
So we're not using the I know we're using the 38, but so we're not using the 3.5 when we're calculating it?
You're using the 50.00? Is that what you're asking me?
Yeah.
Yeah.
Okay. And then so it would be 130, right?
So it'll be 130.
Yeah, it'd be 130. And
30
then,
point what? How many sig figs will we have?
oh, we have 30.
Oh, I get carried away with my zeros here.
40? No, maybe? I'm doing it wrong? I don't know.
How many sig figs should I have?
Oh, 4, so it's 30.4.
I should have 4 sig figs if this is my given.
Oh, no. We only have two. I kept
How many sig figs?
3.
3 sig figs. So either I need to put a decimal point here to let me know that there's 3 sig figs, or I could write it as, and that's milligrams, right?
Yeah.
Milligrams.
And then aluminum chloride. That's actually pretty easy. I was looking at the percentage.
Okay. Or I could also write it as 1.30 times 10 to the, and that's times 10 to the second milligrams of aluminum chlorate. And that's what you were getting, Tiffany. You just forgot times 10 to the second part of it.
Oh, okay.
Okay, so either one would be fine, right?
Okay.
So, but you want to make sure you put your decimal there so that we know that, well, you have your space holder as well as you're saying, I have 3 significant figures. If you're going to write it this way.
Okay.
Okay,
Yeah, I was like double checking. I'm like, how did I get that?
questions, concerns, Cash? Everybody else get it?
Yep.
Okay, can I erase?
Nice. Baby.
Okay.
I can erase now, Andy?
Yeah, I got it. Picture.
Anyone else? Everybody's good?
Yeah, we're good.
Okay. Let's see. Okay. So this is another way that we can go about finding out relationships, right? So we can say things are proportional to each other, right? So we can say that the grams of calcium is proportional to the grams of fluorine, or the grams of calcium is proportional to the grams of calcium fluoride, so on and so forth, okay? And then so we can actually use these proportionalities to sit there and do calculations to save us time. So for instance, so if we're going to try to find the mass of calcium fluoride that is contained in 3.55 grams of calcium, right? We know that we could set up a proportionality between the two. And we can use that proportionality to sit there and give us solutions. Let me show you. Like this, okay? So if we start off with 3.55 grams of calcium, we could sit there and we want to try to calculate the mass of calcium fluoride. So we can say the total, which is 78.08 grams of calcium fluoride, divided by the amount of calcium that we have in there. And so then we can just cancel out the amount of calcium. So this allows us to get a quicker way of coming to the answer, right? Faster way than we've done, rather than having to go through the percentage and then go through, use that percentage to do the calculations. You just do a direct relationship between the mass of the total, in this case, compared to the mass of just the calcium. You guys get that?
Kinda,
Okay.
a little bit.
So you can do it either way. If you need to go through that percentage, go through the percentage, right? Because at the end of the day, I'd rather you take a little bit of extra time going through the percentage and getting it correct than getting it wrong, okay? Okay, so this brings us to empirical formulas. Are you guys ready for empirical formulas? This is the best. It is like, it's money, okay? Are you ready? Okay, so let me tell you what an empirical formula is. An empirical formula is basically, it is the chemical formula that is the simplest that we could possibly get from that chemical formula. So remember when I told you, you got to pay attention to your balancing of everything, making things are equal. And then sometimes you guys would give me stuff like this. Where's Judy? Judy is notorious for this. Love you, Judy, but you are notorious for this. And then I keep telling you, I'm like, Judy, that is a different compound. That isn't calcium fluoride. This would be calcium, it would be called something different, right? So this is why that we're kind of talking about that, because we're getting to that concept of an empirical formula. Empirical formula is getting things to the simplest form that you can possibly get it to. And so you want to reduce to the lowest subscript as possible. Are you there, Judy? Did she tap out? You tapped out. See what happens when you tap out? I talk so much noise about you. Are you guys there?
It shows
everybody
she's
got
in here.
She's in there? She's just
Yeah.
ignoring me?
That's because she's working.
Ah, okay. So I can still talk mess about her. Okay, so we want to try to get it to its simplest form, right? So we want to find the lowest terms of subscripts between each other, okay?
Yeah.
So for instance, we have C4H10. Can we get this to a simpler form?
Yeah.
If so, what are we going to divide it by to get to a simplest form?
2.
2. So if we divide both of these by 2, what are we going to end up with?
C2H5.
2 and 5.
Okay, so this would be considered the empirical formula because it is in the simplest form as possible. You want to give it another shot since, you know, that was too easy? Okay, so let's try this one. So what would be the empirical formula for C6H12O6?
So it'll be CH2O.
Okay, piece of cake?
No.
So it's just like simplifying, right?
Okay,
Yeah,
so
you're just,
you're dividing it by 6, right?
yeah, you're dividing it so that you still have a whole number, right? So I divided everything
Yeah.
here by 6. So CH2O.
Yeah, that makes sense.
Do you see that,
I see it.
Tiffany?
Yeah.
Yeah.
You want to do one
Makes
more?
sense.
Yes, please.
Okay, so let's do.
Let's see, 9?
Yep, that's C9.
Okay, because it looked like an A for a second, so I thought it was calcium.
C3H9O2.
You said H9?
There's 6, sorry.
And then, yeah, O2. Okay. Okay.
Okay, you guys get that?
Yeah.
No.
Who said no?
Matthew.
Matt?
No, that wasn't me.
It wasn't you? Rachel, do you get it?
I get it.
Juan?
Yeah.
Okay, so let's give it a test run. You want to see? Okay. Let's see. Actually, let's do.
Okay. I know it. So it's going to be just C by itself.
Okay.
And then it's going to be 8. I mean, nitrogen 8. And then oxygen 4. Did I get it right?
That is correct.
Woo woo.
Okay. Okay, so now that you guys are familiar with empirical formulas, it's pretty simple, right? Not too complicated, not too hard.
No, it's not too hard. It's pretty easy.
Okay. So we can actually use our percent mass to sit there and calculate empirical formulas, or we can also use our percent mass to calculate empirical formulas, or we could also use grams if we're given grams, okay? And then the way that we go about doing that is by converting them into moles. So the first thing that we want to do is go from mass into moles, because when we're doing comparisons, you know, mass, it's really hard to do comparisons from mass of one element to the mass of another element, right? But if we do moles, then we're comparing the quantity, right? So like for instance, if I weighed apples, right? The weight of 2 apples and 2 grapes are going to be different than comparing the number 2 to 2, right? So isn't that a 1-to-1 ratio of apples to grapes?
Yeah.
Okay, so we always want to convert to moles. Moles is like our gateway, right? It's our gateway drug, okay? So, because then that allows us to do those conversions, okay? So let me give you an example of what I'm talking about. Come on. Clear. Let me write something down so I don't forget. Okay, so a sample of a pure compound is made up of 1.61 grams of phosphorus and 2.98 grams of fluorine. Find the empirical formula of the compound. Okay, so the very first step that we're going to do, I'm going to go through this one first, and then I'm going to have you guys go through a couple on your own. Or not on your own, but we'll go through it together. Okay, the very first thing that we want to do is find out what's given to us. What is given to us?
The 1.61 grams of phosphorus and the 2.98 grams of fluorine.
Okay, so we have 1.61 grams of phosphorus, and you said 2.98 grams of fluorine.
Yeah.
Okay, so we know that this is a compound together. So our goal is to try to figure out what is the empirical formula of the compound. Okay, so the first thing that we're going to want to do is write down what our givens are. So let's go. Yeah, 1.61 grams of phosphorus. What is the symbol for phosphorus?
E.
Okay. Okay, so we're going to start off with that guy. So if I want to change grams into moles, what am I going to use?
You're going to use the mass, right?
Okay, the, what is it called? Is it just called mass?
The atomic
mass.
The atomic mass. Okay, so what is the atomic mass of phosphorus?
Should be 31.
Okay. Okay, 31.
Mm-hmm.
And the units?
Is it AMU? No, grams. Sorry, what am I saying? Grams. Sorry about that.
And then what's going on top?
And then that one's going to be the, is it the 6.02? No, hold on. I'm doing something wrong. It's, what is it? Can someone help me? Is it 100 grams?
1 mole.
1 mole? Yeah, okay.
Yeah, because we want to change it into moles, right?
Okay. I thought it was a 6.02 times the 100, but that's gonna go, that's not, that doesn't apply to this.
Okay. Okay, so now I have the number of moles of phosphorus.
Okay.
So what did you guys get? Do that hard work.
It's going to be 0.05.
How many sig figs should I have?
3.
Is that 3 sig figs?
Oh no, do I need one more? Yeah, one more. So it's gonna be 1.
Is that 3 sig figs?
No. I lied. With a 0 in front of it counts, right?
No.
No, it would be.
Oh no, it doesn't. Yeah.
Moles of phosphorus. Okay, so now fluorine. We'll do that in green, consistent. So we have 2.98 is our given.
Okay, let's graph. It's gonna do the same thing what we did with phosphorus, right?
Okay. So what am I going to do?
So for for fluorine is what? It's 19 grams of fluorine.
I'm putting that at the bottom or at the top?
The bottom, because you want to cross that out.
Okay.
And then we're going to add 1 mole at the top. And then that's going to equal.
That would be 0.156.
Okay. How you guys doing so far? You get it?
Yeah.
Piece of cake so far? So now we can
Yeah.
compare, we have quantity compared to each other. So the best way of doing it is to take the number who's the smallest, who is smaller, 0.0519 or 0.156.
Yeah, phosphorus.
The phosphorus? Is that the smallest number?
Yes.
Okay. So we're going to divide both of these by the smallest number.
Okay.
So that means we're going to have, in terms of quantity, right? It's going to be 1 phosphorus. And this will let me know how many fluorine I have per 1 phosphorus.
And this is, you said this is for the quantity, right?
Yep, quantity, right? Not mass, quantity. Okay, so, oops, I forgot my 1. Shouldn't this be 7?
Yeah, should have rounded it up. Sorry. My bad.
That's right. Keeping me on my toes, that's all.
So would that be 3.02?
That's what I got too.
Yeah.
Okay, so then this has to be whole numbers, right? 3.02, we could just say it's
3.
Fluorine. Okay, okay.
Okay, so then we write our chemical formula. It would be, or our empirical formula, it would be PF3.
Wow. So if if we didn't have the 0 and it was a 5 next to the 3, then it'd be 4, right? 4 fluorine or no?
You're saying that this number gave us a 5 instead of a 3?
That what I'm sorry?
What did you say? I'm sorry.
You know how like when we divided fluorine, so
Yeah.
and phosphorus, we got 3.02. So if it was 3.5, it would be 4 fluorine, right?
No. So if it was
No?
3 so here's the rule. And that's a good
Okay.
question. Very, very good question. Oh my gosh. It's like you're getting me all hot and bothered now. You're
What
starting
was
to
the
ask
question? I
really
didn't
good
hear it.
questions. She was saying like instead of, since it was 3.02, we were able to do a rounding, right? We're able to sit there and just say 3, right?
Yeah.
She's saying what happens if it was just 3.5?
Oh,
Okay.
yeah.
So then in this
Would
situation,
you round up?
no, you won't round up. You want to try to get it to the nearest whole number, right? So then in this case, you'd have to multiply even this number, both numbers, by a way of getting this guy to the nearest whole number. So if we multiply both of these by 2, 3.5 times 2 is what?
7.
7.
7. So then you would have 7 fluorines, but then you'd also have to do the same thing to your phosphorus. So then it would be
2.
2.
Oh, geez.
So then your empirical formula would be P2
That's 7.
F7. Okay. So
Makes sense.
I'm going to give you guys this little hint. So if it's like 0.25, what will I multiply 0.25 to make it 1?
4.
So times 4 is going to give me 1, right?
Yeah.
So if you have a number that is 3.25, then you multiply both numbers by 4.
By 4.
If I have 0.2, what do I multiply 0.2 to give me 1?
5.
If I have 0.33, what do I multiply that to give me 1? Close, really, really close to 1.
3.
3.
3. Yeah.
Hey, Dr. Henry.
That was a
Yep.
tricky one.
I'm sorry to always slow the class down, but can we go back to this 3.5? Like I see where we got the 3.02 and then everything after that I'm starting to
Yeah, it happens because there was a question. I'll go back, but let me give you one more thing before we go, right?
Okay.
So we said if we have 0.5 times 2, that's going to equal 1, right?
1. Yeah.
Okay. So if you have these decimals, then you multiply by these numbers to sit there and make it a whole number. You guys get that?
Yeah.
Okay, so now keep that in mind. Keep that little portion right here. Keep this in mind as we talk about this. So the question was, let's say that we had, instead of, let's see, give me 1 second. Okay, so I'm going to change the problem right here. I'm going to change this guy. Okay, so that was for the last problem. Take a picture of it for the last problem, but I'm going to change it now. Let's say that we have a pure substance and we have 3.4 0.45 grams of fluorine. So this is gone. Okay? So this is going to stay the same, but we're going to go down here and put 3.45. Okay. 3.45. Okay, Matt, I want you to do all the calculations for me for this.
Okay, so where your eraser's at, it's going to be 0.181.
So it's going to be 0.
Or 0.1815.
So then 1, 2.
Yeah.
For 3 sig figs.
Yeah. And then you'll divide that by the 0.0519 to get 3.498. So that would just be 3.5.
Okay, so 3.5. So is that a whole number?
No.
That blue. So that's not a whole number. So we need to figure out a way of making that a whole number, right? So what do we multiply it by to make it a whole number?
A decimal.
We multiply by decimal. It ends with 0.5.
Just add another 0.5.
So
You
2,
can't add. What you do, you can't add it to it because then where is it coming from?
you would multiply by 2.
So you'd have to multiply it by 2, right?
Right.
Okay.
Does that make it a whole number?
Yeah.
Yeah.
Okay. So we multiply this guy by 2. So we also, actually, I'm going to do that in a different color too. So. So multiply this guy by 2. And if I multiply this guy by 2, I also do the same thing up to here, right?
Okay.
So then how many phosphorus am I going to have?
2.
1 times 2?
2.
2. And then how many fluorines am I going to have?
7.
7.
So then in this case, our P is going to be 2, and our F is going to be 7.
Hmm.
Okay, so the key is that you want to have whole numbers, right? These numbers down here, they have to be whole numbers. They can't be fractions, right? 3.5 is too much, right? So you can't just round up or round down because it's 3.5, you know?
Yeah.
So with 3.5, I mean, that's really convenient. What if it was 3.26?
Okay.
Or,
Remember when I look over here, right? That tells you what you need to multiply it by to sit there and get that number, right? So if it's 3.6, right? So if it ends in 0.2, you multiply it by 5. If it ends in 4, if it ends in 0.25, then you multiply it by 4. If it ends in 0.3, then you multiply it by 3. If it ends in 0.5, you multiply it by 2, right? And if it's 0.6, right? So in that case, it's like 0.66, right? To make this a whole number, what do you think I'm going to multiply it by?
6. Let's see, 1 over, say, 2/3. Is that right? 2/3 is 0.66, right? Is that right?
yeah.
So if I multiply this by 3,
Oh, okay.
that's going to give me a whole number, is it not?
Yeah.
And then it's just going to be 2, right?
True.
Yeah.
Is it just the empirical formulas that need to be whole numbers?
Yeah, the empirical formulas, yes. And also down here, have you wrote a chemical equation to this point? Up to this point, have we wrote a chemical equation that have fractions down here? Matt,
Yeah.
have we wrote any chemical equations that have fractions down here? in our substrate?
No.
No. So all chemical equations, right? All formulas should have whole numbers. So you want to make sure that you get it to a whole number.
Okay.
Okay. So if I have 0.75,
Then you would times it by
4,
3
right?
or 4, yeah.
Or because it's 3/4, right?
Yeah.
3/4 is 0.75. So if you just multiply that by 4,
Okay.
so then you're just kind of running back into the same numbers here. So piece of cake.
Okay, thank you.
No problem. Yeah, what you're asking there, that is one of the hardest things to understand, and a lot of students struggle with. So it's okay. I'm glad you asked it. And even if it wasn't the hardest thing to understand, still ask it. Okay, how are you guys feeling so far?
Pretty good.
Pretty good? Okay.
For the ones we see like this, is it always going to be 1 mole?
What do you mean by 1 mole?
I don't know. When I read the problem, like, I'm just trying to figure out how you know it's like we're gonna do it by 1 mole.
I don't understand what you're asking. Well, I mean, what do you mean by 1 mole? You're talking about 1 mole over here?
Yeah.
Well, because what is molar mass? What is the definition of molar mass? Isn't it just the units are grams per mole, right?
Yeah.
Here, you're just changing it to grams per mole. You use your molar mass. All this is your molar mass flipped upside down. It's moles over grams. So you're just inverting your molar mass. Do you understand?
Yeah.
And so it's always understood because it's 31 grams, because that's where you get from your periodic table, right?
Right.
31 grams per 1 mole. It's just flipped upside down. It's inverted,
Gotcha.
right? So does that help?
Yes.
Yeah. And so all you're doing, because molar mass is just an equivalency. So that means that I can flip it. So I always know that I have 1 mole and it's going to be the mass of the element that I'm looking at on the periodic table, that number, that atomic mass that's there, right?
Yeah.
And so then I can flip that any way to get me to where I want to go. Okay, good question. Okay, so you ready to move on?
Yes.
Okay. Okay. Let's see if you guys can do this one. I'm not going to say anything. I'm just going to sit here and look cute. Come on, where's Judy? I'm used to her saying, "You're so conceited." And the rest of you guys, no fun. Okay, while you guys formulate your idea, I'm gonna go get my second cup of coffee.
Oh man, I'm jealous.
Okay.
Now think about everything that you learned. Remember, it's building on itself. So I may want to go back and look at my notes a little bit and look at some assumptions that I made when I had percentages and stuff like that. Okay. How are we going to start? I have my coffee. I'm ready to go. Okay, the question says nicotine is 74.1% carbon 8.64% hydrogen and 17.3% nitrogen. What is its empirical formula?
So you have to divide the percentages by its atomic mass, don't you?
This is getting good. Okay, so the first thing that we want to do is we're going to make an assumption that we have 100 grams of nicotine. So if I have 100 grams of nicotine, how much of it is going to be carbon?
74.1%.
So we're going to have 74.1 grams of carbon.
Yes.
Okay. And then we're going to do the same thing for everything else, for everyone else. So hydrogen is 8.64 grams. Excuse me.
And then nitrogen is 1.23. Or 17.3, sorry.
You gave him the answer.
Yeah.
I was like, oops.
I'm getting a little bit ahead of myself.
Well, you're making me feel better about myself. So I was like, did I do this right?
Okay. So then, what do we do now to get rid of the grams and to change into moles? Are you there?
Oh, hold on, what was the question?
So what do I do to change this into moles?
You divide it by, yeah, you put the atomic mass on the bottom right.
Okay, so what is the atomic mass of carbon?
12.
Oh.
And it equals 6.17.
Okay, 6.17. Okay, so now about hydrogen.
You do the same thing and you divide it by 1.
This is really hard math.
And it's 8.64.
Okay.
And then the last one, you do the same thing, but you divide it by 14. And then that's 1.23.
Okay.
Yeah. That's fine.
So now you divide all the numbers by 1.23 since it's the smallest, right?
That is correct.
All right. Okay. Yes, baby.
That one will be 7, I think. Let's see. Yeah. And that would be 5.
Yeah, that would be 5, right?
That would be C5H7N.
Okay. Okay, so C5. Ta-da!
Yay.
No, but I'm gonna.
What was that?
Oh, sorry, I was talking to my husband.
Okay. Okay, piece of cake?
Yeah, I'm just waiting for the, but then, and then it gets harder.
Dr. Henry, I'm gonna have to log out right now, and then I'll
Okay, that's fine.
be back in the evening class to finish off the lecture.
Okay, so that sounds great.
All right, thank you.
Okay. Are you guys feeling pretty confident so far?
Yeah, that was.
Dr. Henry,
Yes, sir.
why you use 122 divided by everybody?
Because we want to compare them to each other, right? So we want the relationship to them each other, the quantity, right? Because moles gives us quantity. It's kind of like, remember when we were talking about those, the apples and the grapes?
Okay.
So if I have 5 apples, let's not use 5. I have 5 apples and 10 grapes, right? So I want the relationship between my 5 apples and 10 grapes. What is the relationship between 5 apples and 10 grapes? So if I only have 1 apple, how many grapes would I have that would be in the same proportion as that?
So
2?
2, right?
Yeah.
So if I have 5 apples and 10 grapes, so I want the relationship between the two, right? So for every 1 apple, how many grapes am I going to have?
2.
2.
Yeah.
No.
That's right, 2, right? For every 1 apple, there's going to be 2 grapes. So empirical formula is just giving us that, right? So for every 1 nitrogen, I'm going to have 5 carbon. For every 1 nitrogen, I'm going to have 7 hydrogen. The simplest form of the chemical, right? That's called your empirical formula. So by us dividing it by the smallest number, right, we make that one 1, and then everything is proportional to that 1, right? So that's the same thing as saying, for every 1 apple, how many grapes do I have?
So I use the smallest one out of here.
That's right.
Okay. I put use the smallest one.
Okay, so let's use this question for our advantage. Okay, in 1 second. Okay, so if I told you the actual mass Okay, so if I give you the actual molar mass, we can calculate the molecular formula, because in that case, all we need to do is figure out the relationship of the empirical molar mass to the actual molar mass, and they should be proportional to each other, right? Okay, so for instance, what is the molar mass of the empirical formula of nicotine?
Actually, 14.
So how would I calculate the molar mass of nicotine? Oops.
Oh. The molar mass is 162.
No, I want the molar mass of the empirical formula of nicotine. How do I calculate that?
For the molar mass, don't we have to, don't we have to convert it?
Hey, got to go back. Remember, it's building on itself. You can't forget. We talked about this at the beginning of this chapter. Come on, it's there. I know it. Find me in the club. Molar mass.
Isn't it basically like it's always together, right? Is that, oh no, that's molecular mass. Is it the same thing?
Okay, there. Okay, so if we calculate the molecular mass, then how would I calculate that?
It's by knowing, like, say, like how many carbons, or like.
Okay, how many carbons do I have right now?
For carbons, we have 5 carbons.
5 carbons. Okay, 5 times.
It's going to be 12. And
Can you
then,
guys see me over here? Or right over here?
yeah.
Okay.
7 hydrogens. Oh no, but let's add that. So
Okay, so we have 7 hydrogens.
And then for that's going to be times 1, right?
Okay.
And then for nitrogen, we just have that 1 nitrogen, and it's going to be times the 14.
And that's going to equal.
And that's going to equal 14. So so we have the 60, so 60 plus the 7 plus the 14, it's going to be 81.
Units?
Oh yeah, AMU? No, it's going to be grams, sorry, grams. And it's going to be the carbon.
It's just going to be grams per mole or grams?
Grams per mole.
Grams per mole. Okay, so this would be the molecular formula for the empirical formula, right? So we want the molecular formula for the actual nicotine molecule. So this is the molar mass for it, and this is the molar mass for nicotine, the molecule. So to calculate how much I need to multiply the empirical formula by, I just divide the empirical formula's molar mass, or I divide the nicotine's molar mass by the empirical formula of molar mass. So I'll take this 162 grams per mole and divide it by.
The 81 grams per mole, right?
That's correct. And that equals what?
That's going to equal 2.
Okay, so nicotine's formula, chemical formula, would be C, and we multiply that 5 by 2.
Yeah.
Then we multiply that 7 by 2.
Wow, okay. 2 grams.
And then we multiply the N by 2. And so this would be the molecular formula. or chemical formula for nicotine. And this guy's called what again? This is called the what formula?
Empirical formula?
Okay, so this is the empirical formula. Piece of cake?
Empirical formula.
Yeah.
Empirical formula.
Are we good?
Yeah.
Okay, Jessica, you have that look. You're holding your head.
It's a lot, but with practice, it'll be fine.
Dr. Henry, I have a question.
Yes?
When we divided the 162 over 81, what were we trying to get?
We were trying to get an integer to multiply our empirical number by so that we can get the molecular formula, the actual chemical formula for nicotine. So the empirical formula is the simplest form of that, but it's not the actual form. Do you understand?
Okay.
Okay. So by dividing the actual molar mass of the compound divided by the molar mass of the empirical formula, then we're able to get an integer. And that integer tells us what we need to multiply our empirical formula by to get the actual formula of nicotine.
Okay.
So if you look at the actual formula of nicotine, it's this, but this is the empirical formula, the simplest form, right? Because we divided everything by 2 to get to here. Remember that?
Mm.
Any other questions? We're almost done. I know you're getting fried, but we're there. We're like, there's 3 slides till we finish this chapter.
Oh, doctor,
Yes, sir.
you had a question on there. You say the actual molar mass of nicotine is 162.
Yep.
Where you get it from? You just put it there, 162?
I got it from because I know it, right? So it's usually going to be given to you. They're going to give you the molar mass. They want you to calculate the molecular formula
Oh, okay.
of the compound.
You just keep that.
Then-
Yeah, you just keep that so we can calculate it.
Yeah. So you use because typically the way that you would use this is actually used in forensics quite a bit. So let's say somebody poisoned you, and we're trying to figure out the poison that they used to poison you, right? So what they'll do, they'll take a segment of your blood sample. They'll sit there and do isolations, and they'll figure out what that poison is. After they isolate the poison, they'll sit there and do a mass spec, and the mass spec will give them percentages. So we're able to calculate that empirical formula. So then they'll use that empirical formula, and they'll put it in an algorithm to sit there and figure out they'll figure out an algorithm to figure out what integers that it can be multiplied by, and then find the compound that relates to that would cause you to, let's say, have a heart attack, or that would cause you to vomit up your guts, or things like that. So by using the empirical formula, we can figure out what the chemical compound actually is. Okay, you guys got that? Yay, nay, may?
Yay.
Okay. Good. Shall we move on?
When are you said the test opens today, or when are you opening it and closing it?
Oh, the test is already open. It was open last night.
And it closes Saturday or Sunday?
Sunday. Okay, so here's that problem right here. Only thing, this is so much easier, right? It says a compound with an empirical formula of C2H5 has a mass of 58.12 grams per mole. Find the molecular formula of the compound. So what are you going to do?
Okay, so we know that we have the mass of 50.12 grams per mole, right?
Okay,
That's like the main thing we're going to focus on right now.
okay. So
For that, we have to find out what element contains that.
okay. So then what are we going to do?
I think we're gonna find out.
That's cobalt, right?
Yeah.
What was that? You're going to say that, Aaron, please?
We're gonna find the number of carbons and
Okay.
multiply
So-
by the atom, the mass.
Okay, so how many carbons do we have in C2?
2.
C2H5.
So C2, wouldn't that be 12?
C2, how many carbons do I have?
Hold on.
2.
Oh, 4.
I have 2
4, so it'd be
carbons. Okay. Okay, so then I have 2 times 12.
Yeah.
Is that what you're saying?
24.
Yeah.
Okay. So
And
then
we do-
that's 24.
Yeah, we do same for hydrogen.
Okay, and then how many hydrogens do I have?
5.
So 5 times, what is the mass of hydrogen?
1.
1.
So we add these together, we get 29. What are the units?
Grams per mole.
Gram per mole.
Okay. Okay, so then this is the mass of this is the molar mass of the actual compound. So we have 58. What am I going to do with that?
You're gonna divide
So I'm going to divide it by what?
29 grams per mole.
And that equals
2.
2.
2, yeah.
okay. So then my chemical formula for my compound is what?
C4H10.
Okay, because we take this guy and multiply it by, I'll put it times there. Okay? Piece of cake? Okay, questions? Concerns? Cash? Okay, great. So do you guys want to stop here, or do you want to learn about maybe 100 more things?
I'm gonna stop because I gotta get my kids lunch before tutoring at 1.
Okay, sounds good.
So I will see y'all later.
Okay, have a good day.
You too.
So you guys, you want a good breaking point? We finished the chapter. Any questions?
So that's everything, Dr. Henry, for the test.
Yeah, so this is going to be the test. The only other thing that you guys need to know is balancing equations, which you guys have already been exposed to. And it's balancing simple equations. We haven't got to the hard part yet.
I have a question.
I have an answer.
So I took the practice exam.
Yep.
And it brought up a lot of the coefficient questions.
Mm-hmm.
Can you kind of explain that a little bit to me? I think I'm a little lost.
So, oh, that's because it was chapter 8. I have to fix that.